x value less than x1, and you substitute it in the first derivative. When you get a positive, because we started with the case when the first one is a negative. So what if the first one is a positive? When you put in the x coordinate of the turning point, you must always get a 0. Then you pick a value which is above the x coordinate of the turning point distance. You may substitute it and get a negative. So if it is a positive, it is like this. If it is a 0, if it is negative, so if it forms an N-shaped curve, then it means the turning point, which is x1, f of x1, is a maxima. Why a maxima? Because it has got a maximum value of what? Of f of x at some point. For example, that one. Then in the last case, that is when the turning point forms a point of inflection. We are trying to review our paper 1 by introducing the f of x. So if x is x1, if it is like this still, I want to draw them once because this is not so common. For our side, it might be common in paper 1, but this side is not very common. So we need a value on the left and on the right. This is x less than x1. Then this is the x is greater than x1. So this is our sign of the first derivative, and this is its slope. So if you pick an x value which is less than the x coordinate of the turning point, and you get a negative, when you put in the x coordinate of the turning point, always get a 0. And when you put in the x coordinate which is greater than the x coordinate of the turning point, you might still get a negative. So if that happens, it means your slopes will move like that. So when it is negative, when it is 0, and when it is negative again, it slopes down. If it does not appear like that, so it means if it's like this, that is a point of inflection, or we might have it when it is in this shape. So it can be, this is the x coordinate of the turning point, this is left, right, pick a value on the left, pick a value on the right. So if you pick a value on the left and it gives a positive, it gives a 0 and a positive, this is now the sign of f prime. This is the sign of f prime of x, and this is now the slope. So it can move like this, it might move like this 0 and move like that. So if it moves like this, 0 this, then it is still a point of inflection. Though this is very rare in our applied. What is the always common? It is the minimum and the maximum. So let us understand the minimum and the maximum more than the point of inflection. But if it happens in what you are doing, then that is how we handle it. It can better be seen using this one, because when the second derivative is a 0, you may not know whether it was descending b0 and it descend, whether it was a positive b0 and then ascend. So if you realize that you have checked and it is the second derivative is a 0, then you try to pick values on the left and on the right to check how your graph will move. If it is to move like this, then you will move like that. If it is moving like So the very first step is to expand the PDF which has been given to you. So, my examples. Okay, before the examples, we're discussing the steps of finding or what you are supposed to find before you sketch the graph of a nonlinear PDF. The first one, determine the values at endpoints. After determining them, then you went to the turning points and their nature, which we have just concluded. Then you also find the intercepts, though it is not very, very important. You find the intercepts, especially when the graph is going to cross from one region to the other. And how do we get the intercepts? We have the x-intercept. That is where the curve cuts the x-axis. So that is when f of x is 0. Then what we refer to as the y-intercept, because our y is f of x. So at the f of x-intercept, our x is meant to be 0. Then you get those intercepts. But we only find them in cases where you see that in the range given, one value is a positive, then the other one is a negative, one is a positive. Meaning it is going to cut the x-axis, the y-axis at some point when the x-coordinate is a 0. But where you see that it's moving from negative to a 0, or when all these ones have the same sign, they are not relevant. So in our examples, they may say find the intercepts, turning points, and their nature for each of the following. Part A, we can have f of x when it is 1 over 8 x squared. Part B, we can have f of x when it is 1 minus x squared. Part C, we can have f of x when it is 3 over 8 into 2 plus x, then 4 minus x. Then part D, we can have f of x when it is x plus 3, then x minus 3. So if those are the functions, the first step is to ensure that you don't have any brackets, because you don't want to use the other hard math or paper. So you first expand this. But if you can apply the product rule, it's also nice. Although most of you may make mistakes. So you choose to expand, then you deal with the PDF, which is on only one single line, you differentiate. Then we follow the procedures that we are about to follow. So in C and D, you will first expand